Okay, today we are starting on page 22. You will read through the element ratios paragraphs, and then we're going to look at compound ratios. So ratios is something that I know you've been working on in math. So let's take a look at this and figure out the ratios. So on compound A, if something is 67% oxygen and 33% carbon, we're actually going to go with 66% oxygen and 33% carbon. So this is one way to write a ratio. But we need to write the ratio in the lowest form, the most simple form of the ratio. So instead of 66 over 33, 33 goes into 66 two times. So if we divide each side by 33, that gives us 2 over 1. So the ratio for compound A is 2 to 1. Now when you draw them, I just expect to be able to see the difference. Now, the atoms need to be touching in a compound. So we would have 2 oxygen molecules and then 1 carbon. And you can just show that's different by filling that in, or you can color it a different color. That's completely up to you. So let's look at compound B. So we have 80% hydrogen and 20% carbon. So these are both divisible by 20. So that gives us 4 over 1, which we call in a ratio 4 to 1. And then again, you're going to draw 4 hydrogen and then 1 carbon. So compound C, I'll have you do on your own. Let's take a look at compound D. So we have 40, 40, and 20. So we have 40, 40, and 20. These all have a common denominator of 20. So we divide each by 20. That gives us a ratio of 2 to 2 to 1. So you will draw 2 hydrogen, 2 oxygen, and 1 magnesium. Okay. So now what we're going to do is look at page 23. Now you may need to pause this video and work through stuff as you're going, and that's fine. I would recommend that. Number 2, if we look, we have 3 different compounds: compound X, compound Y, and compound Z. So compound X is very similar to compound A on page 22. So you should be able to figure out the ratio for compound X. We'll come back to compound Y in a second. Compound Z is also very similar, but you'll need to pay attention because the amounts are flipped. Now let's look at Y. So Y is 60% nitrogen and 40% oxygen. So each of these have a common denominator of a common multiple of 20. So if we're factoring this out by 20, 60 divided by 20, we have 3. 40 divided by 20, we have 2. So the ratio for Y is 3 to 2. Then you just draw a couple lines in here and draw X, Y, and Z. The next thing it's asking, are compounds X, Y, and Z the same compound or different compounds? So how we know that they are different compounds is because they have different amounts of nitrogen and oxygen in each of the molecules. And the different amounts actually make completely different compounds. If you look at the reading below, it actually discusses this. So you can read this paragraph. It tells that nitrogen and oxygen can form 6 different compounds. So read these 2 paragraphs and it will help you to answer the question above. Then you're going to need to go back up to page 8 and we're going to look at C for a minute. Actually, we're on page 9, I'm sorry. So C. This asks about what evidence have you discovered to explain how knowing the type of matter that makes up each substance determines the state of matter. It's kind of a confusing question. So let's work through that together. So if we know the type of matter that makes up each substance, so different substances, when they combine, sometimes can change their state of matter. For instance, hydrogen and oxygen appear naturally as gases, but when they're combined, they form a liquid, water. So different substances, when combined, can change the state of matter. That's what you need to put in this blank. So you have that. So you can put that in there. We're not going to look at D until tomorrow. Okay, now we're going to get back down to page 23. And we'll move on to 24. So this investigation is about understanding that there are symbols for each element. Please read the paragraph at the top of the page. So here, this is a very simple periodic table. You are going to use a different periodic table to answer the questions below. I have put one on the classroom, which I prefer. I also assigned the McGraw-Hill one. But if you look on your classroom stream, you will see that I included a periodic table. So the first thing we're looking for is carbon. So if you open up the periodic table that I provided for you, you are going to find the word carbon. So if you look at number 6, this particular periodic table, if you click on the element, it will make it bigger on the left-hand side. So the one letter above the word carbon is the symbol for that element. So when you go back to the assignment, when you see carbon, that means next to that you're going to write the periodic element symbol, which is a C. Okay? Then you're going to find gold and potassium on the periodic table and write the element symbol. Now, you are going to then go back to that periodic table and we're going to find what H stands for. So you'll go to the periodic table, you're going to look for the big H, you'll see it's number 1, and that is the symbol for hydrogen. So then you will go here and you're going to write out the word hydrogen. Just a hint, Kr is on the left-hand column on the periodic table. So you'll have to finish this. And then it asks you what patterns do you notice in the element symbols. Are they always the first letter or two letters from it? Not necessarily. You'll find that gold, the element symbol, does not have a G at all, because sometimes they use the Latin name for the element if we're unable to use a letter from the actual element name based on if those letters have been used before in the periodic table. You'll see that potassium is also not a P. So you need to answer question 2. You're going to go on to question 3. Read these 2 paragraphs. This talks about chemical formulas. So let's kind of pull this out. So chemical formulas, this one specifically is for carbon dioxide, CO2. So this is called a subscript, and that tells you how many atoms there are of that element in that particular molecule. Now see how there's no number here? That means there's only 1. So for CO2, we have 1 carbon and we have 2 oxygen. Okay? And this is actually carbon dioxide. It's the air we breathe out. But if there is no subscript underneath the letter, then you know that there's only 1. So you can see 1 carbon, 2 oxygen there. Let's get back into this. You are going to look at these pictures and write the chemical formula. Now, a question came up when in class, does it matter what order you put it in? At this point, no. When you get into high school, you will learn that there is a particular order to write these in. We're not worrying about that now. Let's do number 1 together. So we see here, this is nitrogen, because you can see that right here. So, since there's only 1, there is no subscript. We just put it in. Then if we look here, we have 1, 2, 3 hydrogen, which is here. So we have to put an H, and since there are 3 atoms in that molecule, we have to put a 3. So you are going to do the other 2. And then that is all we did today. The quiz is Tuesday. If you are not in class, I will give directions on that, but you are able to access that at home. If you have any questions, please be sure to email me, and I will get back to you as soon as I can. Have a great day.